So number 8 says solve the system of equations below, write your solution as a point in XY form and check your solution. So there's a lot of things happening here, but we're definitely going to need to make sure we include a check. So, big picture what I have here is these are both linear equations. They both represent lines. And if I have two lines, it's possible that the lines, for example, never meet each other. So you could, think to yourself, oh, if I have two parallel lines, right, they would never meet, and I couldn't find an x or y where they would be together, so there would be no solution. It's also possible that these two equations could be the same equation, right? It's like the line and then the other line drawn again. It's the same line twice. Well, if that's the case, then any xy pair that works in one line would work in the other, and all of those xy pairs would be solutions. The other case, and I think that's the case for this problem, is that you have two lines and they meet at some location, right? And we're finding that location, and there's a certain x value and there's a certain y value that indicate where these two lines meet. And that's what we're trying to find, the x and y values that make both of these equations true at the same time. So I like this particular problem because the very first equation gives me what y is all by itself. It says that y is equivalent to -3 times x minus 2, which is really convenient because I'm going to substitute that value of y into the second equation. So I'm using the method that we call substitution. So I'm going to write this second equation. The second equation is 2 times x plus 5 times y. But instead of writing y, again, I'm going to do my substitution here, and I'm going to write -3x minus 2 in the place of y. And this will equal 16. Now, if I use the distributive property, right, I can rewrite this as 2x plus, let's see, this would be a -15x, and so I'm distributing 5 times -3x, and 5 times -2 is minus 10, and that equals 16. Let's see, next I'm going to go ahead and I'm going to add 10 to both sides so that I get that this equals 26 on the right-hand side. And if I combine my like terms on the left-hand side, I get 2x and -15x is -13x. At this point, I divide both sides by -13, and that gives me that x is going to be the number -2. Now that I know what x is, I'm going to use this value of x in either one of my equations up above to find y. And it actually doesn't matter which one I use. And because that's the case, I'm going to choose to use the top one because it's a lot easier. It always says, right, y is already isolated. That top equation says y is going to equal -3 times whatever x is, and then minus 2. Well, we just found that x is -2, so I'm going to plug that value in. So y equals -3 times -2 minus 2. Y, therefore, is equal to 6 minus 2, so y is equal to 4. So what I found here, it says write your solution as a point. Right? I know x is -2, and I know that y is 4. So this is the point that represents my solution. The final thing that I'm going to do for this problem is it asks us to check the solution, right? So pretty specific. When I ask you to check a solution, this is what I'm looking for. I want you to demonstrate to me that this point makes both of these equations true. So let's consider the first equation there, right? That first equation says y equals -3 times x minus 2. And I'm going to put a question mark here because I'm checking this. The value of y that I found was 4, so I'm going to say 4. I'm going to plug that in, equals -3 times, and x is -2 minus 4. This looks familiar. I just did this problem. On the right-hand side, I've got a positive 6 minus 2, and 6 minus 2 is 4. So I do get the same thing. 4 is equal to 4. So it definitely checks in the first equation. But all that means is that that point is on the line y equals -3x minus 2. It doesn't mean that it's on both lines. So I'm going to go ahead and check the other line and ensure that it's on both. The other one is going to be 2x plus 5y, and I want to set that equal to 16. So what I'm looking at now is I'm going to go ahead and plug in the x and y and just verify that this is true also. Again, x is -2, so I have 2 times -2 plus 5 times y, which is 4. 2 times -2 is -4, and 5 times 4 is 20. And 20 take away 4 is 16, and on the other side of this equal sign, we did have 16. So since 16 is equal to 16, it checks in both equations, and this point, -2, 4, is indeed a solution to the system of equations.